Good morning everybody, myself Acharya Vishvendra. Today I'll discuss OST physics topic card, and the topic of today's discussion is circular motion. So let's begin with point number 1. So circular motion means a particle is moving on a circular path, and its characteristics are that when a particle moves such that distance from a fixed point is constant, then we say that such motion is a circular motion. And this fixed point, as you can see over here, it is called the center of the circle, and the fixed distance is called the radius of the circle. So that is definition of circular motion, locus of a particle. Now let's talk about the kinematics of circular motion. So we have basically three things: the angular displacement theta vector, angular velocity omega vector, and angular acceleration alpha vector. So take the example of a motion in xy plane. A particle is moving on a circular path as shown in the figure, and let's consider 3 points A, B and C on the circle, and particle moves from A to B. Then the direction of motion is anti-clockwise, so angular displacement here will be up the plane, which is along plus z axis in this case. So we can write theta vector as theta into k cap. So that is a standard convention used to find the direction of the angular displacement. So angular displacement is in a plane which is perpendicular to the motion, perpendicular to the circular motion. It may be up the plane and maybe down the plane. It is up the plane when angle is moving in anti-clockwise sense, and it is down the plane when angle is moving in clockwise sense. So this is standard convention used to find the direction of the angular displacement vector. Now if the axis of rotation is fixed, obviously in the circular motion axis of rotation is fixed, then theta here is the axial vector. Axial vector means it denotes the axis of rotation as per the definition of axial vector. Now next point is for anti-clockwise rotation, as in this case we take direction of theta as up the plane, and if direction is clockwise as shown over here, so in this case theta is down the plane. Now the concept here is for angular axis, and even theta and omega, this is applicable to both angular displacement as angular velocity. Obviously angular velocity will be along angular displacement, so theta and omega, direction of theta and omega can be found by the same logic. Coming to the angular acceleration alpha, so alpha is along vector omega if its magnitude increases, and it's along minus vector omega if omega decreases. So this is how we can find the direction of alpha. Now take the case when a particle is moving in xy plane, and it's moving in anti-clockwise sense with a speed 10 meter per second. Now here in this question, angular displacement will be along k cap, angular velocity will also be along k cap, and if its magnitude increases then alpha is along vector omega, but if its magnitude decreases then alpha is along minus vector omega. Now reverse the case. In this case theta is along minus k cap, similarly omega is along minus k cap. And the third consideration will be if magnitude of omega increases then alpha is along minus k cap, and if its magnitude decreases alpha is along plus k cap. Now coming to the seventh point, which is about the relation between linear and angular parameters. So the first relation we have is linear velocity is angular velocity cross r. So this is cross product of omega and r. Here v is the velocity, omega is the angular velocity, and r is the radius vector. So if we found the magnitude of velocity, that is magnitude of omega cross r, so that will be omega r sine 90, which will be omega r is equals to v. So this gives us the result between linear speed, angular speed and radius. Now coming back to acceleration, so we know that acceleration is dv by dt, that is differentiation of velocity with respect to time. This can be written as d by dt, substituting v as omega cross r. Now applying cross the uv rule in this differentiation, we have d omega by dt cross r plus omega cross dr by dt. Now this d omega by dt is the acceleration alpha, angular acceleration alpha. So a can be written as alpha cross r plus omega Now this dr by dt is the velocity, omega cross v. So we have acceleration as alpha cross r plus omega cross v. Now here is the thing. Alpha cross r is called the tangential acceleration, and if calculated, its direction will be along the line of action of velocity. It may be parallel to velocity or may be anti-parallel to velocity. Now there is a point. If tangential acceleration is along velocity, it is parallel to the velocity, speed or magnitude of velocity will increase. Whereas if it is opposite to the velocity, that means speed or magnitude of velocity will decrease. So this is analysis what we can make about the tangential acceleration. So tangential acceleration is alpha cross r, r is the radius vector over here. Now there is another thing which we call as the centripetal or the normal acceleration. So centripetal or normal acceleration is given by omega cross v, and if calculated, its direction is perpendicular to the velocity. Now there is another point of discussion that magnitude of this tangential acceleration is alpha cross r, which is alpha r sine 90, because alpha and radius vector are mutually perpendicular. So magnitude of tangential acceleration is alpha r, or we can say that it is equal to alpha into r. If observed graphically, we can say that graph between AT and alpha will be a straight line and tan theta will be r. So if we have three different cases, three different graphs, then we can see that corresponding to third graph, theta 3 is greater than theta 2 greater than theta 1. That means tan theta 3 greater than tan theta 2 greater than tan theta 1. That means R3 greater than R2 greater than R1. So this is the analysis that we can make. Coming to the next point, that magnitude of velocity or speed increases if tangential acceleration is parallel to velocity. So if tangential acceleration is parallel to velocity, the cross product will be 0 because it involves sine term, and dot product will be positive as angle between tangential and velocity is 0. In the next case, if velocity or speed decreases, then tangential acceleration will be parallel to minus v. Again here at cross v will be 0 because sin at is also 0, but the dot product will be negative. So using both these testing, you can analyze whether velocity is parallel to tangential acceleration or anti-parallel, or speed will increase or decrease. So this is the mathematical condition for increase in speed and decrease in speed. Coming to the normal acceleration, it is omega cross v. So if we find the magnitude of normal acceleration, that will be omega v sin theta. Theta here is 90, so that will be omega into v. So one of the relation is an is omega into v. Another relation is an is v, omega can be v by r into v. So that will be v square by r. Third result that we can make is an will be omega into omega r, that is omega square r. So there are three forms in which normal acceleration can be written in a combination of different functions. Now let's analyze the graphical variations. The first is an versus omega. So obviously if v is constant, that means an will be omega v. So graph will be a straight line and tan theta will be v over here. Next is if we have three different graphs for an versus omega for v constant, then corresponding to the greatest angle we have the greatest velocity. And third is an versus v graph is omega is constant, so obviously an proportional to v, so that will again be a straight line, and tan theta will be an by v, which will be omega over here. Now let's analyze in one more perspective, which is an versus v graph. Omega is constant over here, so here in this case omega is constant. This is the assumption. So if omega is constant, then we can see that theta 3 is greater than theta 2 is greater than theta 1. So tan theta 3 will be greater than tan theta 2 will be greater than tan theta 1. So omega 3 will be greater than omega 2 will be greater than omega 1. Now let's analyze a and v graph when r is constant. So here an can be written as v square by r. So in this case an will be v square by r. So if r is constant, then we can say that an will be proportional to v square. So the graph will be parabola over here. In the next case, if we draw the graph between a and v square, we take v square as x. So graph will be a straight line. And in the next case, if we observe an versus v square graph for three different cases, so we can see that theta 3 is greater than theta 2 is greater than theta 1. That means tan theta 3 is greater than tan theta 2 is greater than tan theta 1. That means 1 by r3 is greater than 1 by r2 greater than 1 by r1. that means R3 is less than R2 less than R1, that means R1 is greater than R2 greater than R3. So this is the analysis that we can make. Now if we see the graph between A and R, so An is V square by R. So if V is constant, so here we have assumed that V is constant, so An proportional to 1 by R, so graph will be a rectangular hyperbola as shown in the figure over here. Now let's analyze graph between A and 1 by R. So obviously here also the concept used will be An will be V square by R. So if V is constant, so graph will be a straight line and tan theta here will be equal to V square. So if we analyze for three different cases, we can see that theta 3 is greater than theta 2 is greater than theta 1. That means tan theta 3 will be greater than tan theta 2 will be greater than tan theta 1. That means V3 will be greater than V2 will be greater than V1. Now there is another relation that An can also be written as omega square R. So if I assume that R is constant, I can say that N is proportional to omega square. So graph here will be a parabola as shown over here. Now if you draw the graph between An and omega square for constant R, so the graph will be a straight line as N is proportional to omega square proportional to x. Now tan theta here is N by omega square, that will be R. So if we have three different graphs corresponding to 1, 2 and 3, so we can say that theta 3 is greater than theta 2 is greater than theta 1. So tan theta 3 is greater than tan theta 2 is greater than tan theta 1. Hence R3 is greater than R2 is greater than R1. So this is the analysis that we can make regarding the graphs. Coming to the next point, so now we have two different cases. In the first case, tangential acceleration is parallel to the velocity and normal is obviously perpendicular to it. So if we see, the total acceleration will be vector sum of tangential and normal acceleration. So here I can write that total acceleration is tangential acceleration plus the normal acceleration, and since these two are perpendicular, so magnitude of total acceleration is tangential square plus normal square. So this is the analysis that we can make. Now thing here is that in this case speed will increase, and as you can see, if we look for the angle alpha between tangential and normal acceleration, sorry, alpha is this angle is alpha, which is angle between tangential acceleration and the total acceleration. So we can say that tan alpha alpha is this angle, not this, alpha is this angle, which is angle between acceleration and normal acceleration. So as we can see from the graph that tan alpha will be at by an. So in this case speed will increase, and obviously angle between at and velocity here, or velocity and total acceleration here, will be beta, and obviously we can say that beta will be 90 minus alpha, and beta here is less than 90 degree. So in this case speed will increase, whereas if we look for the case when tangential acceleration is opposite to velocity, so the total acceleration will again be making an angle of alpha, tan alpha will be 80 by n. But in this case angle between velocity and total acceleration beta will be greater than 90, and in this case speed will decrease. So this is one of the important concept. It has been asked in many PYQs of JEE Main, NEET and even JEE Advanced also. So the concept here is that if angle between velocity and acceleration is less than 90, then speed will increase, and if it is greater than 90, speed will decrease, and obviously if angle is 90 always, speed will remain constant, which reduces the case to the case of a uniform circular motion. Now let's see some comparison of equation of kinematics and comparing linear and angular parameters. So on this side we have linear motion, on this side we have angular motion. So in linear motion we have displacement, on angular motion we have angular displacement. On linear motion we have velocity, on angular motion we have angular velocity. On linear motion we have acceleration, on angular motion we have angular acceleration. Here we have speed, here we have angular speed. Here the first equation of motion is v is u plus integration a dt. Here equation is omega naught plus integration alpha dt. Here equation for constant acceleration is v is u plus at, or in coordinate form v is u plus at. Here equation is omega naught plus alpha t if alpha is constant, and similarly in coordinate form it can be written as omega naught plus alpha t. Here displacement is integration v dt. Here angular displacement is integration omega dt. I have omitted vector here because it's an axial vector, so axis of rotation is fixed. So we can take the work from the coordinate form itself. Here next equation is s is ut plus half a t square for constant acceleration, and here we have theta is omega naught t plus half alpha t square. So alpha here is assumed to be constant. Here equation of motion is v square is u square plus twice integration a dot ds, and here it is that omega square is omega naught square plus twice integration of alpha into d theta. Here equation is v square is u square plus twice integration a dx in coordinate form, and here it is omega square is omega naught square plus 2 alpha theta if alpha is constant. So it corresponds to the third equation. I have omitted second equation over here, so because I have not taken vector over here, and it just coordinate form is sufficient. Now let's see some graphical comparison. So if we have AT graph, so v can be written as u plus integration a dt. Integration a dt can be written as a1 minus a2 plus a3. In the similar way, if we draw the graph between alpha and t, we can see that omega is omega naught plus integration alpha dt, which will correspond to omega naught plus a1 minus a2 plus a3. Then we have second equation of motion. If we have vt graph, we can write displacement as integration v dt, which will be a1 minus a2 plus a3. And in case of we want to find distance traveled, so it is integration mod v dt, or it is equal to a1 plus a2 plus a3. So area under vt graph without sign gives distance, whereas with sign it gives displacement. This is concept for this particular question. Next here is if we have a graph between omega and t, then theta will be integration of omega dt, which will be a1 minus a2 plus a3. Next we have AS graph. So AS graph can be used like v square is u square plus twice integration of ADS. Now this integration ADS refers to area under AS graph with sign. So this can be written as u square plus twice a1 minus a2 plus a3. Similarly, alpha theta graph can be written as omega square is omega naught square plus twice integration alpha d theta. So that will be omega square is omega naught square plus twice a1 minus a2 plus a3. Then we have another concept of displacement during nth second. So in linear equation it is u plus a by 2 2n minus 1. In angular, if we need to find angle traveled during nth second, so that will be omega naught plus alpha by 2 2n minus 1. Here we have linear momentum, mass into velocity. Here we have angular momentum, moment of inertia into angular velocity. Here we have translational kinetic energy as half mv square. Here we have rotational kinetic energy as half I omega square. Here we have force as dp by dt, rate of change of linear momentum. Here we have torque as dl by dt, rate of change of angular momentum. Here we have impulse as change in momentum is equal to p final minus p initial is equal to integration of f dt. Here we have angular impulse as change in angular momentum as final minus initial angular momentum as integration of torque dt. Here we have centripetal force as mv square by r into minus I cap. This is mass into acceleration. So centripetal acceleration is v square by r into minus r cap, as I discussed earlier. So centripetal force can be written as mv square by r into minus r cap, or mv square by r square into minus vector r. One thing is centripetal force is towards center, so it is written as mv square by r. It can also be written as mr omega square or m into omega, as shown over here. So one thing is centripetal force is parallel to minus r, or it is toward the center. Its cross product is 0 with radius vector, dot product is negative, and the angle between centripetal force and radius vector is 180 degree. Analyzing the graph between centripetal force and mass will be, if v and r are constant, so graph will be a straight line. And if mass and velocity are constant, then force will be proportional to 1 by r, graph will be rectangular hyperbola. And graph between centripetal force and velocity, when mass and radius are constant, the graph will be a parabola itself. So this is how we can analyze the various points related to the graph. If you have any doubt, you can ask in the comment section. Thank you and have a nice day.